for something completely different, what we have here is a consonance. You might ask, consonance what? It's a Consonance Preamp T1. It's quite nice looking. It's valve, and the problem with it is, I shall show you. Don't know if you can see in there, but these are rectifier diodes, and check out how loose that is. It's all burnt away. Needs to be resoldered and checked for whether or not the components have died. So I will have to trace the circuit out just to ensure that I'm on the right track, and I will have to load up the whole thing with a variac when I believe I've repaired it. The owner has given me the rectifier diode. Oh, there you go, rectifier. So that's in a little sock to keep it nice and warm and friendly and not hurt. So I shall put that aside for the time being. I won't put it in until I eventually power it up. This is what it looks like. Consonance Preamp T1. Off and on, volume, and for input selection, CD, auxiliary 1, 2 and 3. A fairly basic preamp, but I'm sure it sounds quite nice. So I shall get to it. I've finally got the components that I sent away for. Basically what I've ordered is 5 zener diodes and a TO220 pass transistor NPN for a fairly basic power supply. Raw DC coming in, pass transistor to the output, which is I'm assuming to be approximately 175 volts. The pass transistor is regulated by 5 zener diodes, 36 volts each, giving a total of 180. A small smoothing capacitor across that, and the feed resistor to supply the zeners is a 4K7 2-watt resistor. Very basic zener controlled output transistor, but it should do the trick. So I had to trace all that out, and here is the board. There's the input capacitor, that's the capacitor across the zeners, the 5 zeners, and the output transistor, which is mounted on a heat sink, and that's the resistor for feeding the zeners. These are 2 output capacitors. Well, actually there's only one, sorry. One 47 mic 450 volt, and the other one is used from another rectifier, but just happens to be mounted on this board. It's actually separate apart from the ground. Alright, so what I'm going to do now is try and clean up this circuit board first by trying to scrape away all of the carbon. In fact, I must get rid of it all. We cannot leave any of it there. And some of the tracks have disappeared, but that's okay. We can just join up the zener diodes with their legs. That should work. There's plenty of room. So I'll get to it and do that. Don't know if you can see how dirty it is, but it's not very good. All right, I'll go and do that. Try again. Oh dear. Can't get the angle. Bit of a clean down with alcohol. Okay, all holes are now cleared of solder, so we can move on. Good. Okay. For these zener diodes, how I'm going to put those back on the board, I'll show you with one. They're just a typical, what are they? Yeah, 1N47 series, 1N4753A actually, which is I think 36 volts. Yeah, 36 volts. There's 5 of them in series. So what I do is, first off is get the width of them. Oh, they're all that way. Okay. So, well, it's actually the first one here. So it's quite a small spacing. I use a little one of these spacing tools. It's 1 to 40 on this one, which it's not sure what the numbers mean. Doesn't matter, so long as you measure it against the holes. Okay, so we bend the leads over like that, and we now have our zener like that. Then the next trick is to use this little tool, which has a cup and groove, and what I do is I put them on the legs like this and crimp it. Same with the other side, and we now end up with a device that looks like that. Now you can make that any height you like. You could press it down here if you wanted to, but that'll be sufficient. And the idea is that when you place it in here, it only goes down so far, and it mounts like that. So the diode is now off the board. I forget which company used to do this with all of their resistors and so on. 40 years ago, but that's what they used to do. And if you're keen, you can bend these over to hold it in place, but I try not to do that because it makes it more difficult to get them out. If you can leave the legs straight, it's so much nicer for rework. Now, yes, and the other thing is here is that these won't all be just soldered to the board, because a lot of the pads have now disappeared. Now, one of these actually is going to the other circuit, so I'll solder that one lead. Oops, it's gone a bit wonky. Okay. Now, I've left the other one not soldered because I have to join it up with the others. Alright, I'll carry on doing that. The cathode, or the bar on the diode, goes to where the bar is on the schematic, and in this case it's actually shown as silkscreen on the circuit board, so that's good. Okay, so I think we're now finished. So as I showed on this side, the 5 diodes are now sitting above the PCB quite nicely in air, and on this side it looks a bit messy, but it has to be. Where there are pads, I've soldered the wire on, and in some cases I've actually looped the wire back to its next pad to provide a little bit of extra current capacity. That one there, and this one here I did. It went back to that next pad. The others, the other 1, 2, 3, 4, are actually in the middle of the ladder of zeners, and it's a matter of joining the 2 leads together in 4 cases. Now where there is a pad, I've soldered it, but where there's not a pad, I've joined the leads together in a twisting motion, give them a good amount of solder, and Bob's your uncle. So that's all done. Fantastic. So that will go back in now, and what I will do is bring it up on the variac and just make sure that it's working okay. There was 2 wires here which used to go into one hole, and of course they wouldn't fit now, so I actually drilled another hole right in the nexus of the track and the pad, and so that these 2 can now go in their separate little holes and be soldered in. There we go. So now do the other ones. Soldering wires from the bottom side is not a good idea, but that's how it is, so I have to go with it. So the idea is not to push them all the way through. Okay, well it's all back together now and should just work. But of course we will use the variac and wind up the voltage. I don't have a dim bulb set up at the moment, so I can't do that, but using a variac will certainly, I think, guide me. Yeah, I will have to put in the rectifier valve, because as far as I'm aware, it provides the DC to this regulator. Okay. It's higher than the rest, that's why it have to be careful with it. Okay, I think I've got it mostly connected. I basically have a variac providing voltage into it. I've got a meter looking at the 190 volts input to this regulator, and I've got the other meter looking at the output of the regulator, which hopefully will be about I estimate 175, but we shall see. Nothing more to do than to slowly start turning it on. So Okay, turn it on. Let's bring it up a bit. Oh, we've got some voltages. Okay, so it's warming up. Good. 137, 138. Ooh. I'm surprised there's anything actually. Oh, it's starting to regulate. Good. Yeah, I'll drop back a bit. And they're both 164, 170. So it starts to regulate at around about 170 volts DC. Now this one here is the input, this one is the output of the regulator. 190. That's only at 170 volts AC, and I'm getting the required voltage. It's I didn't think. Oh, see, this is. Yeah, we're getting 177 regulated volts. Yeah, that's fine, but we're getting 200 volts. Unregulated. Well, it must be correct. So that 190 that's written on the circuit board must be wrong. That's a bit sad. I might try an input into it now. Right, let's crank her up again. I've got to wait for the valve to warm up. Okay. That looks like it. Oh, it's working. Good, that's nice to know. Alright, I'll just take it up to 222 volts, that's high enough. Alright, so it's not 190 volts into it, it's well, actually, if we go up to 240, it's 240. Huh. So 240 volts DC, and out is 185. It's a little bit more than I thought it would be. Yeah, it's not the best regulator in the world. It's actually it only works above 170, of course. Yeah, it's still not perfect, but it's only valve, it's probably okay. So let's, alright, we're on 240 volts AC, we're getting 240 volts DC, and 186 regulated out. Terrific, alright. Okay, now it seems to be working now, which is good. It looks like more regulators on this side. There's two rectifier blocks, filter caps, and looks like two regulator transistors. So I'm just going to see if I can take some measurements so that I can just get an idea of if they're okay. Alright, now where was I? Okay, left hand regulator is here, right hand one there. So let's see what we got here. 20 volts and 12. Oh, okay. 12, 12, 20. Alright, okay, so what I might do is drop the volts and just see if we still get the 12. We still get 12 volts. So those two regulators are working. They're both plus 12 regulators. Good. Well, that's about the only electronics involved, apart from this little chip here. I don't know what that does. Something to do with the volume, I suppose. Don't know. Ah, it's a remote control. Ah, it's a powered volume control. That's what it is. All right. Well, he didn't give me the remote to try, but so I think the job is done. So basically, the 12 volt regulator, they're fine. Nothing happened. All that happened was the 185 volt DC regulator got all burnt up. So I just replaced the zener diodes and the pass transistor, and all is well. Doesn't seem to have a lot of gain. But anyway, that's for him to sort out and decide whether it's still anything wrong with it. Alright, well that's about it. I'll pack this up, put the covers back on, and we have a win. Thank goodness. I mean, I'm not all that keen on working on valve gear, to be honest. I've got a few old mantle radios that I need to look at one day, but it doesn't matter if I don't. It's just a project for a winter's day if I've got nothing else to do, which is unlikely. So, well, here it is, finally finished and back together. It seems okay, but to my ears it doesn't have a lot of oomph. Distorts when the volume control is up near the top, and there's crosstalk between the channels on the selector. Pretty ordinary, but perhaps in his system it just comes together and works lovely. So until he tries it himself and is satisfied with it, then we won't know for sure. But I can't think of anything that's really gone wrong with it, so, apart from what I repaired. So that's it for me. All right. Good night, folks.